Hello everyone, welcome back to the channel. I'm Adam, you're watching Seven Steel Fabrication. If you can remember to like, follow, subscribe to our videos, that'd be fantastic. Today in the workshop we're making up a 200 by 90 PFC beam with a 200 by 10 mild steel shelf plate hit and miss welded on the underside. This one's going to be drilled and it's going to have tube ferrule spacers welded into it. This has been drawn up by the builder that we're working with, and this one's going off for galvanizing. So follow on as we build through the process of this beam here in the workshop this afternoon. So the first thing that we're going to be doing today is we've got to clean up the edge of this PFC beam along here, clean the front edge up and the back edge up, ready for welding. This one, and then we're going to mark out the hole spacings for the tube ferrules where they're going to be welded on, drill these with a mag drill. That's the first thing. Then we'll move over to cutting the mild steel flat plate, prepping that, and then transferring everything over to the fabrication table where we'll lay it all up, get everything marked out correctly, positioned up, and then we'll weld the lot up. So the next thing that we've got to figure out now is our bolt hole spacings on that beam. This beam has got a maximum bolt hole spacing on the back of it at 600 mil. And we know the beam itself is 5,265 mil. And we want the first and last bolt hole spacing 85 mil from the start and the end of the beam. So to work that out, we want to take our 5,265 mil minus the two lots of 85 off it. That's giving us a figure of 5095. We divide that now by the 600 mil spacing and that gives us a figure of 8.49. We round that up to 9 now. Now we take our 5095 that we had originally, divide that by 9, that gives us 566. So that's given us a 566 millimeter bolt hole spacing on that. It's keeping us under our 600 mil, which is our maximum. So if we go 85 mil in from the end and 566 mil center to center on the bolts thereafter, we'll end up finishing up with our last one, 85 mil in from the end of the beam, which is exactly where we want it. And we've got equal spacings and equal load carrying over every single bolt over the length of the beam then. These bolt holes as well, they're going to be staggered either side on this PFC as well. So we want them to be centers at 55 mil in from either end. So if we scribe a mark down there, 55 mil on that side, 55 mil on this side. I'll then do the same on the other end in a second as well. That's our two 55 millimeter markings. And then personally, I just like to use just a standard builder's chalk line. Run that right the way through up to the other end. Ping that off. That's our first line. Do the same again for the other one. Pull those down through. Oh, perfect, and ping second one. Lovely. We can now mark out those hole placings that we worked out earlier on. Our first one there was 85 mil, which we were coming in. We mark that point on there, and with the calculator we know we were 85 plus 566. Second one is 651. And next one plus 566, 12, 17, 1, 2, 1, 7, 1, 2, 1, 7. That carries on down the full length of this beam now. That'll give us all of our hole placings for all of our drillings down through. So that's our last line marked up across at a 566 spacings. I don't know if you can see on here, that's set to 85 mil. Bang up to our line. That's worked out perfect, all perfectly spaced now. This lot are now going to have a good center punch mark, put in all of those points down through, so then when we start drilling them out with the mag drill, and we'll have all of the cutting fluid coming out the mag drill, it'll wash our chalk lines away otherwise. So give them a good center punch now, they're there for the whole of the duration. So I'm going to be drilling these out with our rotor broach element 100 mag drill we got. This is one of two rotor broach drills. We got this element 100, and we've also got the little brother of it, the element 50. But currently that's packed away in a box because we had that out on site last week. So while this one is massively overkill for the operation, it does a fantastic job. Where are some glasses? Hang on a minute. We need some glasses. You only get one pair of eyes, you might as well look after them. So that one was drilled here on the top side of the hole. We're staggering them on this lot. So this one has been marked up on the lower chalk line. We will continue to stagger them from this point on down through. Next thing we need to do now is we need to make those tube ferrule spacers. They're cut out of some 42.3 pipe, 3mm walled. We'll whip that through the bandsaw now, get those cut down into the sections. We need 10 of those. We've got 10 holes to go on this one. Get them prepped up and then we can weld those in. Right, so it's time to get these tube ferrules welded in now. We're using our EWM Phoenix 355 pulse. For this, there's a handy little feature on the side here. It's for small jobs, and well, for any jobs to be honest. You can select that setting down there. So you can either have amps or material thickness. So we can just select 4.5mm thickness. We're already selected pulse down here. That's given us 23.4 volts. If you go back to the amps, so that setting's given us 150 amps, 23.4 volts. This machine may be completely different to what anybody else is used to running, and all machines are different. And this is quite, sometimes I think the figures on this seem a little bit different than previous machines we've had in the past, but the results are really good with it. It knows what it's doing, so I kind of just let the machine do what it knows what it's doing best. So we can, yeah, so let's weld them up. Let's try that in a minute. 4.5mm thickness material, see how it goes. Right, so the next thing I need to do, we've got some 200 by 10 flat plate. This comes in a standard 6.1 metre length. We need to get this up on the bandsaw, cut this down to match this beam, then we can transfer them over to the table. So let's get this lifted a minute. Right, so I know I need, we want 15 mil extra on either end for the base plate so we can weld around the end. So we're going to go with 5295. So next thing for us is now that we've got the plate up onto the table, this has been cut down to the length that we need. We're just going to use a grinding disc now and just take off the thick mill scale. Plate mill scale is really heavy. We can always get a better weld penetration between the PFC beam and the plate if we remove the mill scale. So we'll whip over that a minute, take out, I've just marked my lines up through where we're going to sit so we don't have to take more mill scale off than we need to. Clean that down and then we'll drop the PFC on the top, get that lined up, start to mark up and get the clamps on the table and hold that down into position. Right, so I'm going to start to just get a couple of clamps onto this plate now, hold the plate in position. We use these are from a Spanish company called Piher. These are their maxi clamps. This is the Type R, so Type R looks like that. Type F is a bit smaller, kind of get a gist of the difference. But Piher have been really good to us. They've looked after us for a long, long time now. We've been working with Piher for a couple of years as brand ambassadors for them, and I think these are the type of tool that we'll pass down to my grandkids. I just don't see these things ever breaking. We've put them through hell and high water. They've had oxyacetylene heated onto them when we've been cleaning up at plates and bending plates, and they just take it. If you want a good clamp, check out Piher. Right, let's get this one, let's get this girl lifted up. And these sections here, we need to keep this back edge here 10 mil in from the back of the plate. And we want to be 15 mil from here. All right, let's get that set for 10 seconds. It's looking good there. Perfect. Next thing I'm going to do is I'm going to mark up the hit and miss welds that are coming on here. So we, on the drawings that came with this job, we're 100 mil welding, 150 mil off, 100 mil on, 150 mil off. So we'll mark that up on this side and on the other side. We'll do that before we put the clamps on because it just gives us more free space to get in and out to work on it. So I just like to mark these up with chalk. So we're going to be 100 on and then 150 off and 100 on. Now I'm just marking with a small X where I'm going. Now on this side of the table, because we've got our Piher clamps on this side of the table, they're standard ones, they're clamped to the edge to keep distortion from the heat input when the weld goes in from crippling that. But on the table side, we made these up a while ago. These are, you start with a Piher, I think they're the reversible 1500 clamps, or 150, reversible 150 clamps. And we've cut them in half and welded a base plate on the back of them. we now just tack these down to the table with a heavy tack, put them down and lock them down. We've got 6 of these, so we'll put these down, these down the side of the table now, tack them on. They'll stay there, we'll be able to tighten them down onto the top of this. That'll allow us to weld this up with minimal heat distortion in here. If we don't clamp it, it'll end up like a banana. But then saying that, to be fair, it's going to go to the galvanizer, so it'll probably more than likely come back from a banana by the time those lot have had a go at it anyway. Sometimes it feels like you're pissing uphill. So that's all this lot, all clamped up, marked up, held tight. Hopefully we're going to do our absolute best to avoid too much heat distortion in there. We will jump around with all the welds. We'll do one, I normally do one, miss 2, do one, work my way around to that, then come down the other side, go back around. So you end up going around the whole beam 3 times, and it's worked in the past for us pretty good for avoiding too much heat distortion. And that's what we'll do. So I'll weld the first few in along here, and then we'll change over to time lapse, and then I'll whip around, because otherwise you're going to be watching me going around this beam for the next 20 minutes. So that's all of that beam done now. They've been welded with the 100 on, 150 off, all the way around. You can't see it very well there, but it is staying absolutely poker straight at the moment. And considering as it's Friday afternoon, I'm just going to leave this lot clamped here to the table until it's cooled completely. We'll release all the clamps Monday morning when we come back in again. This should be straight as a die. Any questions, drop them in the comments at all. Don't forget to like, subscribe and follow us if you can. And we'll be doing more videos as we go along. So thanks very much. Cheers, y'all. Bye.